Hello everyone. Today we will talk about Thomson's model of an atom. Now, after the discovery of electrons and protons, the next problem was about their position. So J.J. Thomson in 1898 proposed that an atom may be regarded as a sphere of approximately 10 to power minus 8 centimeter radius carrying positive charge due to protons, and in this protons or positive charge, negatively charged electrons are embedded or studded. Now, Thomson's model of an atom is also called plum pudding model or apple pie model because it's also called raisins model because it resembles with plum pudding or apple pie pudding or watermelon. The red part of the watermelon refers to the positive sphere, means the protons, and the electrons embedded in the red pulp corresponds to the negatively charged electrons. So that's why this model is also called watermelon model. So in this diagram, there is a positively charged sphere in which electrons are embedded. Now next is limitations of Thomson's atomic model. So Thomson model was able to explain the neutrality of an atom. Means an atom is neutral because the total positive charge is equal to the total negative charge. But it failed to explain how the positive charge holds on the electrons inside the atom. It failed to explain the stability of the atom. This theory did not mention anything about the nucleus of an atom, and he was not able to explain the observations of Rutherford scattering experiment. So that's why Thomson atomic model was rejected. Next came then the Rutherford's model. Rutherford model of an atom is based on Rutherford's scattering experiment. This Rutherford scattering experiment was performed by Rutherford in 1911. Rutherford performed alpha ray scattering experiment. He just wanted to know the position of two fundamental particles, electrons and protons, in an atom. So for that he conducted alpha ray scattering experiment. Alpha particles required for this experiment was obtained from the radioactive source, and the radioactive element was placed in a box of lead. Lead can absorb all the harmful radiations. Then these radiations were allowed to pass through a narrow slit. After passing from the narrow slit, they were allowed to strike on a very thin gold foil. Gold foil was the source of atoms. After striking with the gold foils, there was a zinc sulfide screen, a circular zinc sulfide screen called the fluorescent screen. This screen, whenever some charged particles strike at this screen, scintillations takes place. Scintillations means flashes of light is produced on the screen. So this helps in identifying the particles. This is another diagram which shows the three important observations of this experiment. So what are those three important observations? Number one, most of the alpha particles, they pass through the gold foil undeflected. Number two, some of these particles were deflected by small angles. And next is a very few alpha particles, one in about 20,000 particles, suffered major deflection by more than 90 degrees and even came back in the same direction. As in the diagram, most of the radiations are going undeflected, and after that few radiations they have been deflected at some angle. whereas there is one radiation which will retrace its path. Now, why Rutherford selected alpha particles? Because alpha particles are the particles which carry 2 unit positive charge and 4 unit mass. So, since he wanted to establish the nucleus, the nature of the nucleus, the position of the nucleus which carries positive charge, so these positively charged particles were selected. So these are the 3 main observations of Rutherford scattering experiment. So how he explained these observations? He simply stated that since most of the particles, alpha particles, pass through the atoms of gold undeflected, this means that they did not come across any obstruction in their path, which simply implies that most of the space inside an atom is empty. So electrons with negligible mass were supposed to be present in this space. Next is, a few positively charged alpha particles were deflected. Now why they show deflections? Since they try to move closer to the nucleus, so nucleus carries positive charge and alpha particles are also positively charged, so that's why due to repulsion or due to repulsive forces, these particles show deflection. Now since these deflections are less in number, so that shows that the size of the nucleus is very small. That's why lesser particles try to approach the nucleus or try to pass nearby the nucleus. Hence we get lesser number of deflections. Now the third observation, that is a very few particles, 1 in 20,000, retraced its path. That means they were deflected at about 180 degrees. So why? How to explain this observation? He simply stated that this alpha particle strike exactly at the nucleus. Nucleus is positive. Alpha particles are also positive. So positive will strongly repel each other. That's why this particle retrace its path. So from there, he concluded that the positive charge and most of the mass of the atom was concentrated in extremely small region called nucleus, which is surrounded by the electrons which are moving in closed path called orbits. The electrons and the nucleus are held together by the electrostatic forces of attraction. So now we are in a position to explain the Rutherford model of an atom. Rutherford model of an atom is very much similar to the planetary system. Rutherford model of an atom, it simply can be depicted in the following points. Number 1, an atom consists of 2 parts, nucleus and extranuclear part. Nucleus is present in the center and the size of the nucleus is about 10 raised to the power minus 15 meter, while the size of the atom is nearly 10 to power minus 10 meter. So size of nucleus is very much smaller as compared to the atom. The positive charge of the nucleus is due to protons. Now since the atom differs in the number of protons, therefore the magnitude of the positive charge on the nucleus differs from atom to atom. Total positive charge on the nucleus is equal to the total negative charge on the electrons. Hence an atom is neutral and is quite stable. Number 4, extranuclear portion is the space around the nucleus in which all the electrons are present. Electrons in the extranuclear portion are not stationary but are revolving around the nucleus at high speed in circular path called orbits. Revolving electrons have certain centrifugal force acting away from the nucleus which balances the force of attraction directed towards the nucleus. He compared his model with the planetary model, in which at the center is the sun and all the planets are revolving around the sun. Same way, at the center of an atom is the nucleus. Around the nucleus, electrons are revolving. Now, there are some drawbacks of this Rutherford model also. So, what are those Rutherford model's limitations? Number one, it could not explain the gravitational force in nature. Number two, it could not explain planetary motion under the influence of gravity. Number three, it could not explain Maxwell's electromagnetic radiation property. What does it mean, electromagnetic radiation property? Now see, Rutherford said that my model is stable. Why model is stable or why the atom is stable? Because there are two forces acting here. One is the force of attraction between the electron and the proton, means positive and negative charge. This force of attraction is counterbalanced by centrifugal force. But what happens when an atom or when a charged particle revolves? It loses some energy. During its revolution, it loses some energy. So when electrons are revolving, then they will also lose some energy. Ultimately, they will come closer and closer to the nucleus. Hence, they will fall into the nucleus. So, atom will collapse. Now, Rutherford was not able to explain this point, that how the charged particle will be releasing the energy, will come closer and closer to the nucleus, and ultimately it will fall into the nucleus. This limitation was put forward by Clerk Maxwell. It was put forward by Bohr on the basis of Clerk-Maxwell theory, which Rutherford was not able to explain. And second important thing is, Rutherford was not able to explain or was not able to give the distribution of electrons, how these electrons are distributed. Thirdly, he compared his model with the planetary system, whereas planets are massive bodies, but electrons, atoms and nucleus, they all are microscopic particles. So there is no match between massive body and the microscopic particles. So that these are the important limitations of Rutherford. Moreover, Rutherford's model was not a three-dimensional model, means it could not explain quantum mechanics as a whole. So these are the important limitations of Rutherford's model. Let us sum up again the important limitations. Number one, why the model was compared with the planet? Because there is no match between the massive and the microscopic particles. Number two, if the electron will keep on losing energy, it will fall into the nucleus. He was not able to explain why electrons do not fall into the nucleus. Means overall he was not able to explain this stability question raises on the basis of Clerk-Maxwell theory by Niels Bohr.